Now let's do an example with a linear substitution. So this will be a bit simpler. So we'll integrate from 0 to pi, 0 to 2y, cos x minus 2y times x plus y dx dy. So the region of integration is a triangular region. And well, from these, looking at the expression, maybe we'll try setting u equal to x minus 2y and v equals x plus y. Looks like a good substitution. So then we have to solve for x and y in terms of u and v. So x we can get by, if we take u plus 2v, then the y's will cancel out and we'll be left with 3x. So x is u plus 2v over 3, and y is, so if we take negative u plus v, then the x's will cancel out, and then we'll have 3y, so y is negative u plus v over 3. So then the Jacobian determinant is, so let's see, u over 3, so 1/3. Del x by del v will be 2/3. And then del y will be negative 1/3 and 1/3. So that's 1 over 3 plus 2. So 1 over 9 plus 2 over 9 is 1/3. Okay. So then again, we need to convert the xy bounds to uv bounds. So let's do that. Okay, so for converting the bounds, again, we can just we substitute in the definitions of u and v, or in terms, so since y was equal to negative u plus v over 3, this is less than equal pi, and 0 less than equal u plus 2v over 3 less than equal to negative 2u plus 2v over 3. Okay, so first we want to multiply out those 3's. So negative u plus v less than equal 3 pi, and u plus 2, that is not, plus 2v is less than equal to 2u plus 2v. So again, let's split up. We have these 4 inequalities and we need to manipulate them a little bit. So this gives us, the first one gives us u less than equal to v less than equal to u plus 3 pi. So that's those are some good bounds for, if we put du on the outside, then we would have like u and u plus 3 pi. So then actually, well, okay, so let's then look at the second set of inequalities. So this one would give, so we can cancel the 2v's to get u less than equal to 2u is just giving us that, negative 2u should be there. So that's giving us that u is less than equal to 0. So 0 is our upper bound for u. And then The other one, though, this one will give us, so 0 less than equal to u plus 2v, if we rearrange, becomes negative u over 2 less than equal to v. So now we have to be careful. We have two lower bounds for v, negative u over 2 and u. Since u is less than equal to 0, negative u over 2 will be greater than or equal to u. So negative u over 2 is really the bound that we need to take for v, not just u. All right, and then what is our lowest possible value for u? Well, again, if maybe this is easiest just to see from u equals x minus 2y, well, we can get the least value by taking x to be 0, and then negative 2y, well, y can be as great as pi. Y goes up to pi, so u will go down to negative 2 pi. Okay, so here's that region. So to sum up, our bounds for u and v is as follows: negative 2 pi less than equal to u less than equal to 0, and negative u over 2 less than equal v less than equal to u plus 3 pi. Okay, so our integral becomes this will be integral negative 2 pi to 0, negative u over 2 u plus 3 pi cos u v, and then we'll pull out the Jacobian determinant in front as 1/3, since this is just a constant, and then dv du. All right, so we can do the first integration. So we'll get 1/3 integral negative 2 pi to 0. This will be cos u times, let's see, okay, now we have to do u squared plus 6 pi u plus 9 pi squared, and then minus u squared over 4 all over 2. Then this du. So that is integral negative 2 pi to 0. So this becomes 3u squared over 4, but then we can divide out the 1/3. So this will cos u u squared over 8 plus, then the 6 cancels with the 2 and the 3 to get the u squared over 8 plus pi u du, and then minus 3 pi squared over 2 integral negative 2 pi 0 of cos u du. And I separated this last term out because this is 0 since we're integrating cosine over its full domain. So we don't need to worry about that term. So this, let's integrate this by parts. So we'll get u squared. So we'll integrate this with respect by parts with respect to this whole thing instead of like expanding it out. So it'll be u squared over 8 plus pi u. Cos u integrates to sine of u sine of u at 0 and negative 2 pi. And well, that will be 0 because sine of 0 and sine of 2 pi is 0. So then the other part, remaining part of integration by parts is negative 2 pi to 0. Then the derivative of this guy is going to be u over 4 plus pi sine of u du. And again, since we'll be integrating sine over its entire domain, the part with pi will cancel out. So we'll just be integrating negative u over 4 sine u du. And that is, so that's 1/4 u cos u. So you'd either do one last integration by parts or just look this up in an integrals table. So the antiderivative is 1/4 u cos u minus sine u at 0 and at negative 2 pi. So 0, both terms will be 0. And we take negative 2 pi. This will be 2 pi over 4, so pi over 2.